All right, we'll go ahead and get started. What I want you to do is open up your terminals and navigate to your folder for the lecture content. Okay, so probably somewhere on your computer you have the 2023 Fall Stats 21 folder. And then what you want to do is you want to pull all of the changes that I've committed to the repository. So you should have, this is under the assumption that you have the upstream repository set up. So again, everybody's upstream should say Smiles Chen to indicate that you are looking at the professor's upstream repository. And you will just type in one command, git pull upstream main, right? And this is going to fetch and merge all of the changes, all of the commits that I have pushed to my own repository on GitHub. So you should see, yours already might have 1-2. This local computer did not have it, but you should see 1-3 being pulled. And so now that should be available. And here it is, 1-3. And with that, you can then launch Jupyter Lab. Oh, that's interesting. Part of the screen on the projector, I think, is cut off just a little bit, but this is what you should see. All right, and you should be able to open up 1-3 basic data types. I'm going to go ahead and move my picture over there. Okay. Is that working for everybody now? Everybody's upstream is all set up, and you can pull all of these changes, right? And that's how it's going to kind of work in the future. Is I'm going to push all of my files, all of my changes to my repository, and you'll download them all using git pull upstream. Okay, git pull upstream main. Okay. Let's go ahead and take a look at today's lecture. So now we're going to just start getting into the basics in Python, and we saw a few of the basics on Wednesday, and we'll look a little bit more at basic ideas. Here we'll talk about some of the data types that are available in Python, and again, a lot of this stuff is adapted from kind of one is our textbook, Think Python, and then the other is, another short textbook, Whirlwind Tour of Python. So, okay, and then what I'm going to do is I'm going to restart and clear all of my outputs. You can have, clear all outputs. I'm going to do this here, okay? Oh, and then, I'm sorry, let me go back and say one more thing. Because I tried to do this on Wednesday, and I couldn't remember the exact command. If you make changes and you want to undo the changes that you've made, okay? So let me go back to my directory. And so, let's say it says, you have these changes and you want to undo them. What you can do is you can reset your thing, and if you just do -- a hard reset, what this will do is it will, any changes that you've made, it's going to undo them all and reset them back to how it was when you pulled it from my repository. Okay. That said, if you didn't want to do that, don't do a hard reset. So a hard reset is very much, I'm going to just wipe out all of the changes. So like if you worked hard, wrote a script, and you want to preserve that, don't ever do a hard reset, okay? Because that's basically like I'm rolling back the time, and you can't, because you never committed these changes, you can't actually like redo them, okay? Like if you want to be able to go back to this moment in time you have to commit those changes to your repository. But a lot of times, as I'm going through these notes, you might like fiddle around and add a couple cells here and there just to kind of play around with it. But you don't actually want to like save and preserve those things. In that case, a hard reset can, just kind of undo and kind of clean out your notes and things like that. To avoid conflicts between when I make changes to, say, my notes and you make changes to your notes or something like that, to avoid conflicts, one thing you can do is you can make a personal copy of a file, and then you'll commit you make changes to your notes, and then you can commit those. I can make changes to my notes and commit those, and those won't be in conflict, okay? Because sometimes when you run into merge conflicts, like I make a change and you make a change at the same time, especially with the Jupyter Notebook, it kind of like breaks the notebook and it blows things up. A lot of times when you're working on coding files and you're part of a team and you're working on scripts and stuff together, you'll want to elegantly merge your scripts changes, and hopefully you don't run into a merge conflict. But yeah, sometimes in Git, it's kind of the idea that two people have worked on the document at the same time, and now how do you reconcile those changes? Okay, and if you encounter that problem, Git might complain that there's a merge conflict, and then you have to kind of manually go through and resolve that. And I don't know if that was covered in your DataCamp homework. If you maybe not, if you do like more of the chapters in the DataCamp homework, or not the DataCamp homework, but just like more chapters on DataCamp regarding Git, they might bring up that topic. Merge conflicts are especially messy for Jupyter Notebooks. So for that reason, if you want to like make your own little notes and changes to your own Jupyter Notebook, I recommend making a personal copy. Okay. Another important thing that I want you to develop as a skill in this class is being able to read and interpret and understand and learn from error messages. Error messages are, sometimes, especially new programmers, when they encounter an error message, that our habit is just to kind of throw up our hands and say, oh, I don't know what to do, right? I don't know what to do in this situation. And I mean, certainly that's kind of our approach for a lot of things, like when your car starts to have like the check engine light, you usually just go, oh, I don't know what to do. I'm going to take it to the shop, right? Unless you feel like, oh, you know what? I've got this, scan tool and I can figure these things out, right? So for a lot of things in life, like when we encounter an error message, we just throw up our hands and say, let's pass this off to an expert, okay? But now that you guys are coding, you have to become that expert that says, okay, this is the error message, and let's figure out what we're going to do, all right? So, and I'm not trying to put anyone on blast here, but on CampusWire, I saw some, a lot of times people post their error messages, and that's totally fine, right? You are all learning, and you're all learning together. And so if you encounter an error message and you're not quite sure what to do with it, feel free to post it up on CampusWire. But a lot of times there's information in that error message that indicates, a solution or where to go. Sometimes an error message will include a message that says, for more information, try going to this website, right? And try going to that website, see what it says. Another thing that you can do is anytime you encounter an error message, is you kind of like copy and paste that error message, put it into Google or search engine, and see what other people have done in that situation. Okay, and depending on what that error message is, you might find solutions and workarounds or something to handle. So I want you to start viewing error messages as clues to figure out how to solve the problem. Okay, so the error message indicates there is a problem, but usually a lot of times there's information or clues within that error message. And as you do more and more coding, you will become better and better and better at reading and understanding error messages. One of I think the biggest things that distinguish a new programmer to a seasoned one is their ability to read and interpret error messages. So as you go, everyone, even the best programmers still encounter error messages. It's just that the best programmers encounter an error message and say, I can understand what the problem is. I can now figure out where to go. And as you know, and this comes with experience, because you're going to encounter the same kinds of error messages over and over and over again. And as you encounter the same error message in the future, you go, oh, I remember encountering this error message before, and I know how to handle this. Okay, so one of the things might be like, how do I export to a PDF? Okay, and if you try to export to a PDF, I think in Jupyter, you can go to like File, Save and Export the notebook as a PDF, and I don't even know if this is going to work on my thing, right? So my thing, I get this error message, right? It says internal server error. The error, Pandoc wasn't found, and I think I've got Pandoc installed on my home computer, but not this current laptop, right? So please check that Pandoc is installed, and it gives me this this URL. And so what I can do now is I can go to this URL, and then I have to install Pandoc, right? So Pandoc is this kind of this program or this utility that takes notebooks and is able to convert them to PDFs and whatnot. So as you encounter different error messages, I want you to start interpreting them or start reading through them a little bit more carefully, and to try to figure out if you can figure out what's going on. And if you still can't, no problem. And again, this is you guys are taking the class together. So, don't hesitate to go on Campus Wire and post your error messages and say, hey, can you guys help me figure out, what's going on here? But yes, I want you to start viewing error messages as ways to solve problems. Okay, let's talk about our value types. So we have different types of data in base Python, and there are other important data types that we will use after loading libraries like NumPy and Pandas. So in NumPy we have the NumPy array, and in Pandas we have the data frame. But that's going to come later. For now, we'll start off with kind of some of the most common data types, which will be strings, integers, floats, booleans, and kind of the important none type. All right, so strings I think we're familiar with. That's for like text data. Integers are integers, basically whole numbers and negative number values. Floats are anything with decimal points. Booleans are true or false values. And then none is used to indicate that something doesn't exist, okay? Like a null value. All right, we also have structures to kind of contain these things. And so we have ordered structures like lists, tuples, and ranges. We have things that map values to others, which would be a dictionary. We have unordered structures like a set, and then we also have binary things that can be stored as bytes. All right, our first, so you have this function called type, and this will just tell you what kind of type a value is. So if I put the number 2 in quotes, this will be a string. So here I'm kind of navigating through my notebook, and I'm going to hit Control Enter or Shift Enter. So here I get quote 2 is string. Type on this value 2 with no decimal points is an integer. 2.0 is a float. If I put in the keyword true, capital T, lowercase RUE, that tells me that's a Boolean. And if I use the keyword none, I get none type. Right? So this is just This is the function that we use to figure out what type something is. Okay, we have basic mathematical operations. So we can take we can add values, we can multiply, take the difference. Perhaps the ones I just need to point out, we have integer floor division. So this is kind of like if you do 23//5, what is the whole component? That's going to be a 4, right? And then whereas the mod operator will say, 23 mod 5 will give you a remainder of 3. The exponentiation or power operator is star star. You can also do absolute values. So here I'm going to do 10 and 5, and the types on these 10 and 5, these are both integers, right? Okay. If I do 10 plus 5, I'm going to get 15. 15 is going to be an integer. So that's that. If you multiply two integers together, then you'll get back an integer as well. So if I do 10 times 5, I'm going to get 50, and that's going to be an integer, no problem. Division always results in a float. Even if the result is an integer, Python is always going to store the result of division as a float. So 10 divided by 5 is 2, but Python's going to say this is a float. And to indicate that it's a float, when you print out the value 2 as a float, it's always going to have a decimal point. So it's going to say 2.0 to indicate this is a float, not the integer 2. Anytime, if one of your values is a float, anytime you, if you add it to say an integer value or multiply it with an integer value, it's going to result in a float. So 10.0 plus 5 gives me 15 as a float, 15.0. 10 times 5, 10.0 float, 10 times 5 will give me 50 as a float. I'm not sure how well versed you are in how numbers are stored or how floating point numbers are stored in your computer, but even though these look like decimal values, they are not real numbers. That's an important thing to remember. So if you think about, say, the number pi, 3.141592653, whatever, how many decimal points are there? There's infinitely many, right? Obviously, we're not going to store infinitely many decimal points of pi. I'm going to choke on some here. So we just stored an approximation, okay? And every decimal value, any kind of irrational number, square root of 2, you only get an approximation, maybe up to 16 decimal points. 52 binary bits is what's being stored in there. So all numbers are kind of stored as 64-bit binary. 52 of those bits are dedicated for kind of the fractional component, and that creates a limit. Okay. The largest possible value you can store in floating point is 1.797 times 10 to the 308 power, which is a very big number, okay? But it's certainly less than infinity, okay? This is a little bit less than the number 2 to the 1024. So I could do 2 to the 1023. I can do 2 to the 1023 plus 2 to the 1022. Plus 2 to the 1021, technically up to like 2 to the whatever 1023 minus 52 is, and get a value, and I would get this. If I try to do 2 to the 1024 as a floating point number, I'm going to get an error. I get an overflow error. It says, this number that I get, it's too big. I've run out of spaces. It's it's the same problem. You know, did you ever have like an old school calculator that had like a fixed number of values in the screen? You know, what happens if I try to do, so let's say I fill up the screen with nines, and then I say, let's add one, right? Maybe you tried this as a kid, and you said, like, what's going to happen when if the whole screen is nines and I try to do a one? And then, and I don't know if you can see that, but it says error. It says, it gives you, you know, 1.0000, and there's an error, and then you try to add one again, and it doesn't work anymore, right? And that's basically the calculator saying, I've run out of storage space. I can't represent this number anymore because I only have, you know, eight digits on this screen. I can't show you any number that's bigger than 8 nines in a row. And basically the same thing's happening here. We've got internally, we have 64 binary, you know, ones and zeros. And basically this number is like, it's not quite, but it's almost everything is filled out. And now, you know, if you try to add another number to that, it says, well, I can't do that anymore. And so you get that. That's an overflow error, okay? And then there's technically the opposite problem. There's also an underflow error where, you know, what's the smallest value that you can represent on this calculator? It's going to be 0.00000, and then you have a 1, right? You got a bunch of like leading zeros and then a 1. And then if you say, hey, what if I want to divide that number by 10? Your calculator is going to say, I can't represent that number anymore because I don't have enough decimal places, right? So, I mean, so that, you know, then you get like the scientific calculator that can do more. But you know, on this kind of thing, it says, you know, I don't have space for it, you know, to show anything, you know, smaller than 10 to the negative 8. And similarly, there's a limit for the smallest number we can represent here. You know what? There's a few side effects. So if I do 1 plus 2 over 10, this is 3/10. 1/10 plus 2/10, also 3/10, is A equal to B. We feel like they should be equal to each other, but they're not. Okay? And that's like in real numbers, these are equal, but in computer numbers, they're not. Okay? And we can tell Python to print this out with showing 20 places after the decimal. And we can see this number, 1 plus 2 divided by 10, is 0.299999999, you know, 8890. And this number, 1/10 plus 2/10, is 0.300004441. Okay? This is kind of like the thing I like to compare it with is, you know, if I do what is 10 divided by 3 on my calculator, and I hit equals, I get 3.333333. Okay? And if I say, hey, I'm going to take this number, 3.33333, and I'm going to multiply it by 3, right? What am I going to get? Okay? I'm not going to get 10. I'm going to get 9.999999, right? And so we're kind of like asking, is 10 divided by 3 times 3 equal to 10? And we know the answer, of course, should be yes. 10 divided by 3 times 3 should be equal to 10. But on my calculator, 10 divided by 3 times 3 is 9.999999 and not 10. And that's basically what's happening here. You get these weird side effects of having a limited range of values that you can represent. Okay. Sorry. This thing where this is how you can, I'm using the format operator to print out a whole bunch of decimal places. There is a function called math is close. And this is kind of like, it's not a test for equality, but it's just saying, are these two numbers similar or very close to each other, okay? And then that's going to come back true. But, there's a limitation, right? What if somebody says, I want to store the number 0.3333333333333, okay? So it's not quite a third, right? They wanted like 303,333,333 divided by 10 million or something, right? Is that equal to 1/3? No, it's not equal to 1/3. But if you ask math is close, it's going to say, yeah, those things are close. So there's, and I think they check to see if it's the same up to like, I don't know, 12 or 14 decimal places. I forget the details on that. We can ask for help. Okay. Integers, on the other hand, there's no actual upper limit. So I can do 2 to the 1023 as an integer, and it tells me whatever this number is. It's a really big number. Okay, 2 to the 1024 is this, and I can keep going. 2 to the 1025, and my computer is actually able to handle this. So for integers, it uses a variable amount of memory, and it says, oh, you want a whole bunch of bits for this integer? Sure. And it gives you a whole bunch of values here. Okay. The exponentiation operator, if it results in a integer, it'll output an integer. In base Python, there's no square root operator. You have to import the math library. So if you do square root, it's going to say, I don't know what you're doing. But if you don't feel like loading the math library and you want a square root, you can exponentiate to the 1/2 power, and it gives you pretty much the same thing. Okay. There's no a lot of kind of things that we expect actually aren't part of base Python. You have to load the math library. So if you ask for pi, it says I don't know. The exponent function, it says I don't know. Sine function, it doesn't know what to do with any of these things. But we can say I want to import the math function or math module or math library, and then we can call math.square root, and that works. Math pi, math exponentiate function, math on the sine function and stuff like that. Okay, and these work. Boolean is capital T, lowercase RUE. Oh, you know what? Let me give you view quiz answers. View quiz number 1 is B. Okay. Okay. True is capital T, lowercase RUE, and Jupyter should recognize when you type in capital T RUE, it'll like change the color of this as you're typing, right? So if I type in true, suddenly it becomes that, right? If I do false, it doesn't, but if I do capital F ALSE, that works out. It doesn't recognize other kinds of spellings. It has to be spelled with a capital T and lowercase RUE. True in quotes is a string, right? And then again, this is the only accepted spelling of true and false for Booleans. Okay, everything else it's going to think of is like a variable name or something. And by the way, never name your variable true. You're not allowed to name variables with capital T RUE. But it's also just a really bad idea to name a variable all caps true or something like that. And in general, don't name your variables T either, okay? You might want to be like at time 0 or something like that, okay? Say time, okay? Just because T is a little bit fraught with things. In general, avoid using one-letter variables. One-letter variables are good for like iterators and counters, like I and J. Those are those are like your exceptions for one-letter variables. Or like if you got a simple math expression and you want to use x and y and z, that's okay, like exposition and stuff like that. But if it's something else, try to avoid single letter variables. It's only if you're like implementing some kind of math expression where we understand that this is the variable x or this is the variable y or z, that makes sense. But if you're trying to say like, okay, this is going to represent, how many students or something like that, don't write s or something. Okay, that's going to lead to confusion. Okay, strings, we got this. There's a couple functions. Strings are stored as technically iterables. So you can say how many characters are in the string, and this one says there's 19. You can replicate something with multiplication. Hello, how are you? And you can say fine, 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 fine. You can also format strings with little placeholders using curly braces. So here I can say over here I've got a variable and it contains the value miles, and I can do my name is curly brace name, and my school is school, and then over here I'm going to take this string, dot it, use the format method, and I can say name equals name and school equals, and I can actually plug in just a string right here, and it will insert your strings in here as placeholders. Okay, and then this is basically what I did here with the curly braces is also what I did back here where I formatted this text. After you put in the variable name, you can also use a colon and then specify how you want the that text to be formatted. So in this case, it's I want to kind of format the thing with 20 values after the dot is basically what's happening there. Okay, assigning values to names or variables is done with the equal sign. The name always has to be on the left-hand side, so you can never do 5 equals n. It's always n equals 5. When you assign a value, Python just does it. It doesn't output anything to the screen. If you want to see it, you can print it out. Variables in Python are pointers, okay? If you've ever worked with, say, C, C++, or Java, when you define a variable, you're defining like a bucket in memory, and that bucket or that position spot in memory is going to store certain types of values in there, okay? So you might say, I'm going to define an integer x, and we're going to put the value 4 inside that integer, okay? And then, so if you try to put the number 4.1 in there, it's gonna either error out or complain or something, okay? In Python, we just say x equals 4, right? And what we're doing here is we're defining a pointer called x, and this value x points to a bucket in memory that contains the value 4, all right? And we don't actually have to declare any variables. And so if we want to change this, what x is pointing to, we can do that, okay? So Python is dynamically typed. So I can just run all 3 of these things in succession, and I can say, all right, I want to change this name x, and I want to point it to a different value in memory, the number 1. Okay, I want to point it to another value in memory, a string, hello. I want it to point to a list that's stored in memory. So these are all things, so it just kind of dynamically creates values in memory, and then it also creates a name that says this name points or is a reference to this value in memory, is what it's doing. And Python has something called a garbage collector, where it says, okay, I used to have this, or I have this number in memory, the number 4, but I don't have anything pointing to this number 4 in memory, okay? I don't have a way to kind of, this number 4 that exists in memory, I don't have any names pointed to it. So Python just says, oh, you know what? We're going to go out, we're going to collect the garbage, and it says, sorry, number 4, nobody remembers you anymore. We're going to clear out the space, okay? So that we can put values in here, right? Just so you're like, you don't have these giant memory leaks where like all of this stuff keeps accumulating and piling up in memory and things like that. So that's kind of a nice feature of Python. Technically it slows down the operation of Python compared to other languages, but it also just eases up the programmer's mind and like not having to worry about keeping track of things. Yeah.
So that example where you have x equals 1, x equals hello, and then that,
Uh-huh.
you can't refer to because once it
Yeah, once it moves on,
define it
yeah, you can't go back.
delete the last one, so you can't access that, right?
Yeah, you can't go back and get the hello anymore. Yeah, it's X is now pointing to this list 1, 2, 3, and then like, yeah, what happened to hello? Well, yeah, sorry, it's gone. Okay. You can choose almost anything to be a variable name, almost, right? There's a few rules. Names have to start with a letter or an underscore, okay? So you can have letters, numbers, and underscores, right? And then when I say letters, I mean ASCII letters, so not, well, I don't know. Can we do Unicode now? Maybe. But in general, and I mean, this is very America-centric, but, programming, you should limit your characters in your scripts to just be ASCII characters. So basically, US keyboard, you got the 26 letters there, lowercase and uppercase. Limit yourself to those. Okay, you don't want to start putting in accented characters or foreign characters, none. So that's just kind of the thing. We got underscore characters, no symbols other than the underscore, no spaces, and it can't be keywords, and these are your keywords. Okay, false and true, none, as well as these other ones. Naming your variables, this is pretty tough. Okay. There's a joke about this being the hardest thing in programming, is coming up with good variable names. So again, single letter variables, not great. Even just SID, something like that, is probably not great. But variable names that are way too long, also not great either. So here we have Finnish Meteorological Institute Observation Station Identification Number. That's going to be cumbersome, right? So you can do FMI station ID separated with underscores. That's pretty good. FMI station ID. This is known as camel case, and that's pretty good. Lower camel case starts with a lowercase letter. Upper camel case starts with an uppercase letter. And then when you call snake case, you use underscores. I personally generally tend to use snake case, but camel case is very widely accepted and popular as well. Other things that are helpful when naming variables is, if the thing that you're going to have is a list containing multiple values, then it makes sense to use a plural name rather than a singular, right? So here I've got fruit. This list is stored with the name fruit. It'll be better if we call it fruits, right? To kind of indicate, we're going to have multiple things here, okay? Even better is to call it fruit names, okay? Because it's containing strings which are the names of the fruits. So that's pretty good. Okay, if you're going to store something that is a Boolean value, a true false, it's preferable to turn your variable name into a kind of a yes/no question. Okay, so rather than selected true, you can say is selected. Okay, or write is true, you can say can write, or writable. Okay, or something like that, right? So these are kind of just things to consider. I mean, these aren't like hard rules that say you must do this, but just for your own benefit as you write more code and you want to be able to read your code easily. I mean, so my brain is very, I can only think in English, and when I read code in English. And so there's kind of this, I don't know, there's like this translation mechanism happening in my brain as like I read lines of code. I'm also translating it into kind of English where I'm thinking like, okay, this is what this thing is doing. And so having words rather than just letters makes that translation process a little bit easier for me. And that's a recommendation there. Okay, let me give you your next view quiz answer. So answer 2 is, okay. For numbers, just kind of, any kind of descriptor here. So using just the word rows is very kind of ambiguous, but you can say like minimum rows, max rows, total rows, current row. Those are probably better names for some kind of numeric value there. Function names. So functions, we like to think of these as like verbs in Python. And so if you're going to come up with a name, you can use basically a verb, right? And some functions in Python will modify the object. So in that case, use an action verb. Other functions don't actually modify the object, but it will return a value. And this value will be like an operation that was done with the object, but it doesn't actually modify the object. So in that case, use like a passive form of the verb, okay? So an example of this is in Python, you can create a list and then you can sort it or alphabetize it, okay? If it's numeric, you would sort it from least to greatest. If it's, got strings in it, you can alphabetize it. And so there is a function called sort, and this will take the list and it will modify the list by sorting it, okay? And then there's also another function called sorted, which doesn't modify the list, but it takes the list and gives you back a sorted version of the list. So here I have a list called car brand names, and I've got these names in it: Ford, BMW, Volvo, Toyota. And I can say, take this list and sort it, okay? And what this will do is it will take the list and actually sort it. And so when I call what is car brand names now, the list itself has been modified to be put in alphabetical order. So now the list itself is in this order, okay? Whereas here's a different function, sorted, okay? Takes this new list and it doesn't modify it, but it returns back a sorted version of the list, okay? So, these are subtle differences, but it kind of gives you an indication as far as the philosophy and insight of how Python works with these different things. Okay, and the way we call these things is a little bit interesting. This is a standalone function, and over here I have the list car brand names dot sort. This is actually a method that is attached to this list itself. Okay, so here car brand names was Chevy, Chevrolet, Audi, Honda, and I say give me back the sorted list. But we can see that the original list here is unmodified. If I try to say, give me this thing and it calls dot sorted, it says, I don't have a dot sorted, okay? The method is dot sort, so dot sorted doesn't exist. And then if you try to call sort as a function on the list, it says, that thing's not defined either, okay? And this is something that's probably going to take a little bit of getting used to when you first use Python, because certain things that you want to do are standalone functions, and then other things that you want to do are methods attached to the object. And this is just part of learning the vocabulary and grammar of Python, right? So if you think back to when you took a foreign language and you had to learn okay, this word, I don't know, I took Spanish and I did not do great in my foreign language, and I tried downloading Duolingo and I just deleted it to avoid getting haunted by the bird. But anyway, there's just part of this, you just have to kind of learn the vocabulary. You have to learn, okay, these words work in this way. This verb or this word, has this gender or whatever. That's a thing in Spanish. And similarly, and whenever you learn a new computing language, and in this case Python, you learn, okay, this action is a method attached to the object. And this action is a standalone function that can be applied to objects and stuff. And that's part of the learning here. Okay, let me give you your last view quiz answer and we'll call it a day. So answer 3 is C. Okay. Okay, so we'll end here for today. And again, if you don't want any of these things stored away in your, after you shut down, so I'm gonna shut down Jupyter Lab. If I do git status, it says I've modified this. And so if I just kind of want to reset all of this, I'm just going to do git reset hard, git reset -- hard. Sorry, what happened here? And this undoes my changes. Okay. All right. Have a great weekend.